Okay, good day, good day. I just want to show you on how you can answer. This is simply the continuation from where we ended on the dimensional analysis. So on that dimensional analysis, I gave you two examples. There is also another example that I want to show you on how you can use to check the correctness of the equation. If at all the equation that you have been given, it's its dimensional analysis is what? Correct. So here you have this. We have been given use dimensional analysis to check the correctness of the equation. This is the equation. So now, in order for us to check the correctness of this equation, the input here on this v should also be equal to this one and also to this one. So you are going to get the same thing in whatever that you are going to do. So that's what we call, when we talk of the correctness of the equation. So remember, this is v. So now this v, which is the velocity, so this one will represent the final velocity. Then this one is going to represent the initial velocity. Then we know this a is acceleration, then t is time. So here we are saying that if at all we are able to, or we need to put out the data, we are saying that v is equal to final velocity, and then u v or which is initial. This one will represent initial velocity. And then a will stand for acceleration. And then t will represent time in seconds. Okay, so something like this. So here, to prove this, so to answer this one, we'll say where there is v here, you put the dimension. So remember, this is speed. So speed for v, we say that it's, the formula is L, which is length, and then over time, okay, is equal to, so even there, which is initial, it's going to be L, length over time. Then plus, here this is acceleration. So acceleration, you know that it's also length over time squared. Then times, there's times t, we just replace capital letter t like that. Then from there, you say this one, it will be, it's L, then over t, then plus, so there we've got 2t, you say L over it's t times t, then times t this side. So this one we can divide this one, and this one will do what, will reduce to 1. So what are we going to remain with there? That's what t. So you are going to have L over t, then plus L over t. So this one, this side you've got L over t. So as you can see, throughout the equation we've got the same dimension. So we've got the same dimension. This is L over t, which is velocity. Even there is velocity. Even there is velocity. So here we are saying that, so having this, all this is what we call dimensional analysis. So therefore we are saying that the expression v is equal to v initial plus a t is dimensional dimensional collect. It's dimensional collect. It's dimensional collect. Yes, so this is how you are supposed to do it. So for this one, we are done. We've proven to say this equation is dimensional what? Collect. As you can see, we've got LT is equal to LT plus LT. So this is what? Collect. So here the second one, we have this one. A particle moves with a constant speed v in a circular orbit of radius r, as shown in the figure below. So this is the circular orbit, and then it is able to, it has got the radius, this r, and this is what the acceleration there, this is where the velocity is. Then given that the acceleration a, so there is acceleration a, which is this one, of the particle depends on the velocity v, which is this one, velocity v of the particle, and the orbital radius, which is this one, and orbital radius. Use the dimensional analysis to derive an equation that relates a, v and r. So here, for us to come up with the equation, as we know that this acceleration, we are told that it depends on. So this acceleration, we are saying that acceleration depends on v and r. Yes, so this is what we have. So what we are going to do, we are going to introduce what? A constant dimensionless variable. So a constant, let's say we are going to introduce k as a constant variable. So we say a is equal to k as this. Then we have v. So as I've said that after you write something like this, so we are told that acceleration here, acceleration depends on velocity and also what? Radius. So now we introduce the constant. So once we introduce the constants, which means this v, we are going to find the value of what? This v. So now in order for us to find the value of velocity, at least we'll raise this to the power of what? A certain letter. So let's say here we use m, then r again, we can say r to the power n. So if you want, you can also use other letters apart from what? M and n. So now having this, so now we are going to replace using what? The dimensional analysis, because we are using the dimensional analysis to derive an equation. So now in order for us to derive an equation, we need to find the value of m and also the value of n. So what we are going to do here, we'll say where there is a there, we know this is acceleration, and acceleration we write as L over t squared. So this is what? Acceleration is equal to, so here we've got constant k. Yes, we've got k. Then v here we say it's v, we say it's L, then over t, like this. So there we are saying that there is what? There is m. So here there is what? M, we'll say m. There is m, where there is v, and then times again, times we have this one, this is just a length, which is L to the power n, like this. So this is what we have for now. So we have this one and we have this. So
when you are, as we can see here, we can do what, we can multiply these two. So this base and this base are equal. Yes, are equal. So what do we do here? We'll say, so multiplying these two, we are saying that when you are multiplying numbers of the same base, you maintain the base and add the powers. Okay, so here we'll say it's L again over t squared is equal to, so this m we can separate this, so there is L to the power m, then there is also t there to the power t m. Okay, so here we are saying that when you multiply these two, which means we are going to maintain L, then you add this, it will be m plus n. Okay, there's what, multiplication where there is k. So k is being multiplied by this. So as we can see this, we can equate this one to like length, it will go with what, length, time with what, time. So having this, we are saying that our m, this and this will cancel, so we are going to have m is equal to 2. So this m, which means t and t, is going to have this t and this t will cancel, so the power we are going to have m is equal to what, to 2. Then you've got L and L, so these two L will do what, will be cancelled out. So what we are going to remain with is the numerator, and there the power is what, 1. So I'll write it from here. We have m plus n is equal to 2, or is equal to 1, sorry, 1. Then you know that your m is equal to 2, so which means where there is m, you replace by what, 2. So there where there is m, you say it's 2 plus n is equal to 1. So in this case, the equal sign, it will be n is equal to 1 minus 2, which will give us n is equal to -1. So this is what we have. So having these are values of m, n and m. So now we'll get this value and replace in this what, equation, in this expression. So we are going to replace it there. So once you replace, what are we going to have? Let's say there we are saying that you have a is equal to k there, then v. So where there is vm, you replace by 2. So there we'll say it's 2. Okay, then r, there is r there to the power n. So n is equal to -1, so you say -1 like this. So this is what we have. Then so now we know that any number less to a negative power, it's a fraction. So rewriting this, just this one here, to leave it in a positive form, we'll say it's a is equal to k v squared over r, like this. So this is how we can write the expression, the relationship of a, v and r. So this is what the final answer. This is how you can answer the questions that relates to show the relationship between different what variables.